Okay? To further master this kinematic equation, so let's have another example. A particle moves along a straight line such that its acceleration is a is equal to 4t squared minus 2 meters per second square, where t is in seconds. When t is equal to 0, the particle is located 2 meters to the left of the origin, and when t is equal to 2 seconds, it is 20 meters to the left of the origin. Determine the position of the particle when t is equal to 4 seconds. So first, let us remember the different kinematic equation. So at A, we have A is equal to dv over dt. Our V is equal to ds over dt, and S is simply your displacement. So the problem is that we would determine the position of the particle when t is equal to 4 seconds. So determine the S at t is equal to 4 seconds. So how will we solve this one? We all know that our acceleration is equal to dv over dt and our velocity is equal to ds over dt. Therefore, substituting your value of v, we have acceleration is equal to the derivative of your displacement with respect to time. This is the equation. But in order for you to not be confused, so let us use this equation first. So our A is equal to dv over dt. Okay? So using this equation, we will have a value equal to the acceleration, which is equal to 4t squared minus 2. Acceleration, which is equal to 4t squared minus 2. This is the value of our acceleration. So manipulation of your equation, so we have dv is equal to 4t squared minus 2, close enough in parentheses dt. So getting the integral of both of the equation, so we'll have v, which is equal to the integral of your 4t squared is 4t raised to 3 all over 3 minus 2t plus c. Okay? So to further integrate your v is equal to 4t cubed over 3 minus 2t plus c, it will give us your position or the equation of your position. So since you already know your v, so let's go back to that equation where v is equal to ds over dt. So v is equal to ds over dt. We all know that your v is equal to 4t cubed minus 2t plus c1. So therefore, we may say that 4t cubed all over 3 minus 2t plus c1 is equal to our ds over dt. By cross multiplying your dt, so we will have a value equal to 4t cubed divided by 3 minus 2t plus c1 multiplied by dt is equal to our ds. So in order to get the equation of your ds or of your s, so therefore we will integrate this, or we will integrate your v. So we'll have an equation equal to 4t raised to 4 all over 3 multiplied by 4. From the integration formula, u raised to n plus 1 all over n plus 1 plus c. So minus 2t squared all over 2 plus c1 multiplied by the integral of dt is equal to t. So take note that your c1 is your constant one at velocity. And then if further integration of this one, for your second integration, we will have your c2 plus c2. Okay? Is equal to your s. So take note that we use the concept of your indefinite integral calculus. Okay? So, upon manipulation of your equation furthermore, to simplify it, we will have a value equal to 4 divided by 4 is 1. So, we have t raised to 4 all over 3 less t squared plus our c1t plus c2 is equal to s. So, therefore, this is the equation of our s. But have we answered the question in our problem? Particularly no, because the problem wants us to determine its position at t is equal to 4 seconds. So therefore, let us consider resolving the displacement or your s into an equation wherein we can find the value of your c1 and c2. So therefore, we have finding our c1 and c2. Finding c1 and c2. We all know that we can solve this one by using the clues given to our problem. So according to our problem, t is equal to 0. So since we are in one-dimensional motion, we will only consider our x-axis or your s-axis. S-axis. So at t is equal to 0, our particle is located 2 meters to the left of the origin. So 2 meters to the left, we have the particle. This is your particle at t is equal to 0. So our s is equal to negative 2 meters. At t is equal to 2 seconds, at 2 seconds, so our particle is located 20 meters to the left of the origin. So at 20 meters, we have negative 20 meters. So let's say this is negative 20 meters. So your particle will be located at 20 meters from the origin, which is 0 at S0. Okay. So the origin that the problem is talking is its position. Okay. Or at 0 origin or at 0th value of your S. So upon knowing this, we may say that we can use these two relationship wherein we have our at t is equal to 2 seconds, we have our s equals negative 20 meters. Okay, so using this relationship, we may say that we will substitute it to this equation in order to find for your c1 and c2. So substituting values, substituting at t is equal to 0, our s is equal to negative 2 meters. Therefore, we may say that t is equal to 0, so we will have t raised to 4 minus t squared plus c1t plus c2, which is equal to s, which is our equation of our displacement. So we have t is equal to 0, so we will have 0 raised to 4 minus 0 squared plus c1 multiplied by our t multiplied by 0 plus c2 is equal to s, which is equal to negative 2. Okay, so cancelling out all these equations or these variables with 0, because 0 multiplied by any variable or number is always 0. So therefore we have c2 is equal to negative 2. This is therefore the value of your c2. So upon knowing the value of c2, let us solve for the value of c1. So take note that at t is equal to 2 seconds, our s is equal to negative 20, right? So solving for the value of c1. Okay, so we have our equation, which is t raised to 4 all over 3 minus t squared plus c1t plus c2 is equal to s. So knowing that our t is equal to 2 seconds, we have our s is equal to negative 20. Therefore, we may say that, or we may substitute your t, which is 2 raised to 4 minus 2 squared plus c1 multiplied by 2 plus c2, which is equal to, our c2 is equal to negative 2. Okay, so we will substitute your negative 2 plus negative 2 is equal to s, right? So 2 raised to 4 over 3. So we'll have a value equal to, use your calculator as you go on with our calculation. So 2 raised to 4 all over 3 less 3 squared less 2 squared plus negative 2, which is equal to negative 2/3. So we have 2c1 less 2/3, which is also equal to, our s is equal to negative 20. Therefore, we have 2c1 equals negative 20 plus 2/3. We will have a value equal to negative 58 over 3. So solving for c1, so we have c1 is equal to negative 58 over 3 divided by 1/2, which is equal to negative 29 over 3. This is the value of our c1. Okay, knowing that this c1 is equal to negative 29 over 3, therefore we may substitute all the equations or the value of your constant easily. So our t raised to 4, which is equal to negative 29 over 3. So we have t raised to 4 over 3, t raised to 4 over 3 minus t squared plus c1t plus c1t plus c2 is equal to our s. Knowing that our c1 is equal to negative 29 over 3, so we have t raised to 4 over 3 less t squared less 29 over 3 multiplied by t less c2, which is equal to negative 2, equals s. This is our this is the equation of our s. Okay, this is the exact equation of our s. So we already know the c1 and c2. So after knowing your c1 and c2, let us solve for its s at, solving for s at t is equal to 4 seconds. So how? By simply substituting the value of your t raised to 4. So we have t raised to 4 all over 3 minus t squared minus 29 over 3t minus 2 equals s. Actually, you can use your calculator in solving this one. So alpha x raised to 4 divided by 3 less alpha x squared minus 29 over 3 alpha x minus 2. Okay, so we will have the value of your 4. Calc at t is equal to 4 equals s is equal to 28.667 meters. So in case you are not aware of that in as a function of your calculator, so let us use this. Okay, so let us use our calculator in solving that one. Okay, if you are using your 991 ES, okay, just press alpha and then the variable x, alpha x, okay, alpha x raised to 4 over 3 minus alpha x squared minus 29 over 3 alpha x minus 2. Take note that you would substitute the value of s into x because you would just input the function as it is, letting your s is equal to x in your calculator, and then press your calc. So the calculator will ask you what will be the value of your x, and then according to the problem, the value of your x, or which is equal to, actually equal to t, variable t pala, so which is variable t, it is asking the value of your x, which is the value of my t at 4 seconds. So therefore equals 28.667. If you want to turn that into its fraction form, so just press your s to d. Okay, but if you don't want to use that, so you can just use the value 28.6667. So if you would round this up into its nearest hundreds, so we'll have 28.67, or in your 2 decimal point. Okay, so this will be our value of our s. So notice that this subject needs the mastery of your both integral and differential calculus. So maybe you are just taking your integral calculus, but probably the basic of integral calculus were already discussed in your classes. So this will be our third example.